The following triangle is to be overlapped by 25 small triangles that are similar to it. Find the sum of the sides of the small triangle. Okay. Sum of the sides is called perimeter. So they're asking you to find the perimeter of small one. So it's covered by 25 triangles. What they meant was they are covered with something like this. So here, for you to have 25, you have to have 5 on each side because this is two-dimensional figure. So therefore, 5 times 5 is 25. So you are supposed to understand that you're cutting it into 5 pieces each side. However, this wording is wrong. They say overlapped. That means I could do this, right? That means I could make it any size I want. And what they should have said was the large triangle is covered completely without overlap, not overlapped by 25. Overlapping by 25 triangles, so I could make any size I want in any shape I want. This is a valid one, you know? And I could make one of them very small and say, well, the perimeter of that triangle was 0. It was very small, you know? So this problem is basically nonsense because they didn't say that. But suppose we go with the original meaning. They said 25 triangles, it covered by 25 triangles without overlap. Can we still solve this problem? I have created this diagram for you. I split this the original triangle in the problem into 25 smaller, similar triangles. I accomplished this by making parallel lines. Let me take this out and show you the figure I have. How I did this was this side and all these sides are parallel to each other. At the same time, this side and these sides are parallel to each other. At the same time, this side and these sides are parallel to each other. That guarantees that these triangles you see in them are similar to each other because they are by SS, you know, they all become the corresponding angles. Now, but the thing is, do they have to be the same size? See what happens here. If I move it around here, I don't get the triangle. This one is not even a triangle, and I have more than 25. You can count them, or less than 25. Something is messed up somewhere, and you don't get these nice triangles anymore. By the way, all the triangles you see in them are similar. It's guaranteed because they are parallel. It doesn't matter how I distort this. They will remain similar. However, there are many figures that are not triangles. For example, this one is not a triangle. This one is not a triangle. So seems to me initially that it has to be parallel. I mean, the uniform size. I have a hard time doing it. Let's see. So if you put your effort into this, you will be able to construct 25 uniform size, similar triangles. So, but having similar size is the only way. I mean, having the same size, the only way to get 25 similar triangles in here. Can you make non-equal size 25 similar triangles into this? So let's investigate here. How many triangles do I have here? It's 25. I can tell without counting because it's divided into 5 pieces and 5 pieces. That becomes 25 automatically. But let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. I want you to notice this is 1, 4, 9. This will be 16. And this will be 25. You know that, right? 17, 18, 19, 20, 21, 22, 23, 24, 25. Now, the question is, can I have 25 similar triangles without making them the same size? I would say yes. How do I do that? Let me show you. Let me erase this here. Okay, because the way I drew with the parallel lines, this is a similar to the previous one. So I got this, okay? So I got 22 triangles. So I changed the size, but I messed up the count. This is supposed to be 22. But can I make 25 somehow with a different size? The answer is yes. I could cut it in half here. And I can draw like that. It would be 23, 24, 25. So you could give an answer of this triangle's perimeter, and still they have to consider it right. Not only that, you could do it again. You could just merge these into this one triangle like this. Notice I'm losing 3 when I do this, right? I got to gain 3 more similar triangles somewhere. I can get it from here. 24, 25. So one that I lost, I can put in here. Here. I got it. So I can lose 3 more here. And then cut this into smaller triangles, and there we go. And I could, and so on and so forth. So therefore, I could make quite small triangle and claim that that is similar, and without overlapping, they nicely cover the entire original triangle. Wow. So what's happening here? This is supposed to be a precise math problem that should have only one answer. The problem was the wording of it. They said 25 small equal-sized triangles or congruent triangles. They should have said that. And they should not have said overlapped. They should have said covered without overlapping. Then it makes sense. Then you have a triangle that is 1/5 on each side. So this one would be 1/5 of this, so it would be 30. This side would be 1/5 of this one, so it would be 40. And this side would be 1/5 of this, so it would be 35. So if you add them, 70 would be 105. Would be the answer they were looking for if they worded this correctly.